It's a today topic is a PO4 mathematics content, which is sadly joined merged with what do you call that algebraic fractions in PO3 mathematics, but it's a PO4 mathematics topic. PO mathematics 4. Right. Now, what you need to understand is, but initially we know that if you add these ones, we will get x plus 1 plus 2 times of x minus 2 or something. How we supposed to do this one is we can take the LCM. What is the LCM over here is x plus 1 into x minus 2. Then 1 you can multiply with x minus 2 and plus 2 with x plus 1. So with this you get the answer x minus 2 plus 2x plus 2 divided by this is, so shall we make this 3, but other than that you don't get a clear idea with that. So you can say it's 3 and 3, right? Okay. Then if you do this, you get the answer 3x minus 1 over x plus 1 into x minus 3. This is the same thing what we did in our small grades. Right, okay. But this is not the partial fraction today. The topic is partial fractions. Partial fractions chapter 1, right? Okay, this is chapter 1. Okay. Then but our doubt is this way. They ask about this way. 3x minus 1 divided by x plus 1 into x minus 3. Then they ask to write in partial fractions. Write in partial fractions. Write in partial fraction. The idea of the making partial fraction is Pute, using this fact, how to write it into break into this format Pute. That is what you mean by the partial fraction. You need to write, you have to break them into fractions by parts, just like it's like partly fraction, that is called the partial fraction. That means you need to write the reverse process of that. Let's see how to do this question. This is a simple way of doing it. Right. How to do this question today? You can say 3x minus 1 x plus 1 into x minus 3, and we can break them into two fractions today. You can write, you can break this denominator in this format today. X plus 1, I just a and b, you can put it later, x minus 3. You can break this into two fractions today. Then write this numerators with some kind of letters you like. You can put A, B, O, P, Q, whatever you can use it. Then we will take this right hand side and simplify this today. We will work out the LCM for this part and we will do it today. X plus 1 into x minus 3. Then you can say A times of x minus 3 plus B times of x minus 1. Sorry, x plus 1. X plus 1. X plus 1, then it's equals to 3x minus 1 divided by x plus 1 into x minus 3. Now you can see the numerator. A, x minus 3 plus b, x plus 1. Now if the denominators are similar, you can equate these numerators. That's the logic behind this. Right? Now let's see how to do this question. Right? What you can do here is, initially I need to find the value for a and b. Then if I make this x equals to minus 1 from this logic, if I make this bracket 0, I can get some answer for a straightforward. How to make it? X plus 1 equals to 0 means x equals to minus 1. Then if you replace minus 1 over here, you get this bracket 0. Then what do you get? 3 times of minus 1 is equals to a times of minus 1 minus 3 plus b times of minus 1 plus 1. It's turned up to 0. Then you get the answer minus 4a is equals to minus 4. With this, you can write a equals to 1. This is pretty simple. Then, if I need to find the value for b, I can make this bracket 0. How do can make it? By making x equals to 3. Now look at this. If I put 3 here, it's become 0. So you can write 3 times of 3 minus 1 is equals to a times of 3 minus 3 plus b times of 3 plus 1. It's turned up to 9. 9 minus 1 is 8 equals to 4b. Therefore, b is equals to 2. Right. Then you can write a is 1 over x plus 1 plus 2 over x minus 3 would be the partial fraction answer for this question. Hope you can understand this section. Right. Okay. That's a way of doing it. We'll go ahead with another example. This is the answer for that. Then let's go to another example. We will get 6x plus 1 divided by x plus 1 into x plus 2. We will see. Write them as a partial fraction. Question is, you should write this one as a partial fraction. So I'll use a different color to write the answer. This is a question. You can make this equal. You can break this denominator by x plus 1 plus x plus 2. Right. Then what you can get here, you can write this one as a and b. You can put any letters you like. I just put a and b because of the first two letters. Then take the LCM of the left hand side. So you can say a times of x plus 2 plus b times of x plus 1. The logic behind here is, wait, I'll show you how I get this answer. X plus 2. The LCM is a product of these two. It's written over here. Then to get this one, cover this denominator from here. That means this is covered. Then what is the remaining term? X plus 2. Then multiply a with x plus 2. Right? Okay. That is done. Then if I need to find what is the number to be multiplied with b, cover this denominator from here. Then what is the remaining? X plus 1. Then multiply b with x plus 1. That is the logic for this. We just did some things in our small grades as well. Just to anyway, just reviewing. 6x plus 1 over x plus 1 into x plus 2. Right. Okay, that's great. Then, since the denominators are similar, you can straightforward equate the numerators. You can write 6x equals to a times of x plus 2 plus b times of x plus 1. Right. Okay. That's great. Okay. Right. Then, if I need to get a, I need to make this b bracket as 0. How can you make it? By making x equals to minus 1. Look at this. If I put minus 1 here, this is turned up to 0. So you can say 6 times of minus 1 plus 1 equals to a times of minus 1 plus 2. And this is b times of minus 1 plus 1. So it's turned up to a is equals to minus 5. Minus 6 plus 1 is minus 5. Right. That's a way of getting it. Then if I need to get b, I just want to make this a equals to 0. So you can put x equals to minus 2. Look at this. If I put minus 2, this is turned up to 0. 6 times of minus 2 plus 1 is equals to a times of minus 2 plus 2 plus b times of minus 2 plus 1. Then what you can get with it? You can say minus 12 plus 1 is minus 11 equals to minus 2. This is 0 minus b. Minus 2 plus 1 is minus. So b is equals to 11. Then you can write your final answer this way. A is minus value, b is plus value. So you can write minus 5 over x plus 1 plus 11 over x plus 2 would be the answer for this. That's a way of getting this answer. This is pretty simply, you can get this answer. Then we will move up to the next level of this question. That means this denominator contains 3 fractions. For example, it can be 8x plus 4, or just a constant, even it can happen. X plus 2, x plus 1, x minus 3. We'll get this way. Right. This is the question. We need to break them into partial fractions. We need to break them into partial fractions. So what can we do here is the answer. I will use a different color to show the answer. I can make them into equal. There are 3 fractions. So So you can write like this. The first bracket is x plus 2, the next bracket is x plus 1, and the next bracket is x minus 3. Right. Then what you can do with this is you can label with any letters. You can write P, Q, and R, whatever. It doesn't matter. You can use any letters you like. Then take the LCM for the left-hand side. What is the LCM over here? LCM is x plus 2, x plus 1, x minus 3. Please concentrate for this question clearly. Then which number should multiply with P? Just this is the technique. Just cover x plus 2. Then what are the remaining? X plus 1 and x minus 3. X plus 1 and x minus 3. Then what are the number should multiply with Q? So I'll just erase this. Now you cover x plus 1. What are the remaining? X plus 2 and x minus 3. X plus 2 and x minus 3, right? Then which number with multiply with R? Cover x minus 3 from here. What are the remaining? X plus 2, x plus 1, right? Okay. So now already written over here. This is similar to literally 8x plus 4 divided by x plus 2, x plus 1, and x minus 3, right? Okay. Now you can say, since the denominator is similar, sorry, you can equate the numerator. P times of x plus 1, x minus 3, plus q times of x plus 2, x minus 3, plus r times of x plus 2, x plus 1. Right, okay. Then what you can get here is, I need to find the value for P. Concentrate this clearly. To find P, I need to make this P, Q and R 0 at once. So you can see how can we make both at once at 0. So you can see x plus 2 is common for this two. Then if I make x equals to minus 2, what you can see? This bracket becomes 0, therefore this whole term becomes 0. This one also turn up to 0, therefore this whole thing should be turned up to 0. Therefore I just make this x equals to minus 2. So if I repeat it, to find P, I need to remove Q and R from this expression. The common bracket is x plus 2. By making x equals to minus 2, this term you can turn up into 0, and this term also you can turn up into 0. So it gets put it. 8 times of minus 2 plus 4 is equals to P times of minus 2 plus 1 minus 2 minus 3. So my minus 16 plus 4 is minus 12 is equals to minus 6 into minus 1 is 6p. Sorry, minus 5p. No, sorry, it's 5p. I just made a mistake. Minus 2 minus 3 is minus 5. Minus 5 into minus 1 is 5p. Therefore, yeah, it's p equals to minus 12 over 5. Doesn't matter, these fractions, they're what you call this constant at the numerator can be 0. It's not a problem at all, right? Okay. We'll go ahead with a bit of it, right? Now, if I need to find the value for Q, how do you find the value for Q? You can make P and R at once. If you can make P and R at 0 is 1 at once, we can make it. Is there any common bracket for this? Yes. X plus 1 and x plus 1. So if I make x equals to minus 1, what you can see, this bracket 0, so therefore this whole term becomes 0. This bracket also turn into 0, therefore this whole expression becomes 0. Sorry, this term, actually not the expression, this whole term, right? So I just put it and see. Minus 1 plus 4 is equal to P and Q. P and R become definitely 0, so you can find the value for Q. Minus 1 plus 2 minus 1 minus 3. Let's turn up to minus 8 plus 4. Minus 8 plus 4 is minus 4 is equals to, this is minus 4 into plus 1. It's minus 4q. Therefore, q become how much? 1. It's pretty simple. Right. Then we can get the value for, we just try to make up to find the value for r. To find r, what you can do? To find r, I need to remove p and q from the expression at once. P and q. The common bracket for p and q is x minus 3. Therefore, I just put x equals to 3. But what happened? This becomes 0, so it's not there. This becomes 0, therefore this whole thing is not there. 8 into 2, 8 into 3 plus 4 is equals to this way. Put it. And C, it's R, 3 plus 2 times of 3 plus 1. So it's turned up to 5 into 4, 20R is equals to 28. 28. Therefore, R become 14 over 10, 7 over 5. 7 over 5. Doesn't matter. I told you like it's possible. Then how to write with this fractional answers as a factor for this? P over x plus 2. So the answer is P. P is minus 12 over 5 times of, according to this one, it should be x plus 2. Q is a complete number, doesn't matter. 1 over x plus 1. And R is how much? 7 over 5. So it's pretty simple. You can write 7 over 5 times of x minus 3 is the final answer for this. It can be just this kind of like fractional answers for this constant at the top. It's not possible. It's not a problem. So it's always, it's kind of a possible situation because most of the problems where we come across is it in that format. So nothing to hesitate on that. That's the answer for this. That is the second approach. The first approach is, if you just go up, sorry, it's just like the fractions with two denominators, what you call denominators with like two expressions in the denominator. Next approach is if you're having this kind of like three denominators in the, three expressions or three terms in the denominator, right? Okay. Then the next approach is just like this, right? That means you can get this kind of expressions, just like this. You can say 4x plus 1 over, this is x plus 1 times squared into x minus 2, right? This is a question, right? Then how are you supposed to do this? Then you can see there is a power of 2 in the denominator. In that situation, we can write like this. That's a fact we need to understand. You can write first denominator is x plus 1 and the second denominator is x plus 1 squared. And the third denominator is x minus 2. Because when you are having a power term, all the minimal term, or what you call terms with the minimal order should be written. From the next example also, you will be verified with that, right? Okay, and that means if it is a, just I will use another one, just like this. We'll explain that question later. That is, if it is like 3x plus 2 divided by x plus 1 cube. If it is so, you should write all the minimal orders of this term today. That means you had to write like this. The highest order is x plus 1 cube. Therefore, you can write x plus 1, x plus 1 squared, x plus 1 cube. All these three terms should be written. Right. Okay. Let's go ahead with this question today. Right. Okay. Then we can fill up with this way. With A, B and C. Now the LCM part. LCM is x plus 1 squared, can x plus 1 into x plus 1. Split like this, that would be easier for you to understand this question. X plus 1 squared into x minus 2 is the LCM. Therefore, just split x plus 1 squared as x plus 1 into x plus 1. Then which number should multiply with A? Just cover this denominator, this one from here. Remaining is x plus 1 into x minus 2. Right. Then from here, which number should multiply with x plus 1 squared? X plus 1 squared should be covered. Both terms get covered, so remaining is x minus 2. It's C. If you cover x minus 2, remaining is x plus 1 into x plus 1. Yeah, now that is a fact. Therefore, since the denominators are same, this term is remaining as it is. You can say 4x plus 1 is equals to a times of x plus 1, x minus 2 plus b times of x minus 2 plus c times of x plus 1 into x plus 1. Right? Okay. Then for the, how do you supposed to do? Straightforward, I don't think that I can find A, because the reason is that there is no common brackets for B and C. So initially I try to find out the answer for B. To B, the common bracket is x plus 1. So I'll just put x equals to minus 1 over here. Then what do you get? 4 times of minus 1 plus 1 is equal. So you can see if I put minus 1, this term becomes 0. And minus 1, this term also becomes 0. So we can write B times of minus 1 minus 3. Minus 4 plus 1 is minus 3 is equals to minus 4b. Therefore, b become 3 over 4. Right. Then again, I'll try to find out the answer for C. To find C, you can see the common brackets for A and B is x minus 2. So I just put x equals to 2. By putting x equals to this one, you can turn up to 0, and this one also you can turn up to 0. That is 4 times of 2 plus 1 is equals to, I can find the value for these two terms become 0. 2 plus 1, 2 plus 1. So it's turned up to 9c is equals to 9. Therefore, c become 1. Yeah, c become 1. Right. Then I need to find the answer for A. To find the answer for A, I don't see any common brackets to simplify. In that sense, what you need to do is you can put any figure you like, but it not should be any of this answer what you already substituted. I just put 0. It's kind of easier for me to do it with it. 4 times of 0 plus 1 is equals to A times of, now we have to put it everything. Now you know the value for B. Therefore, I can straightforward, you can put this. I know the value for C as well. Yeah, then it's turned up to 1 is equals to, this is minus 2A. Right, this is turned up to minus 8 over 3 plus 1. So with this you can say 2A equals to minus 8 over 3 plus 1 minus 1. With this you get the answer A equals to minus 4 over 3. This is pretty simple. Right. Then you can write the final answer. This is, sorry, A over x plus 1. A over x plus 1 means you can say minus 4 over 3 x plus 1. B is B over x plus 1 squared. Yeah, then C. C is, according to this one, C is 1. It's 1 over x plus 2. It's the answer for that. It's x plus 2, right? So x minus 2. So I get it. It's x minus 2. So like that, you can finish up this answer, right? And now I'm going to use the same technique to answer this question as well. So here this, since this is power is 3, you can write all the minimal orders. I can put A, B, and C. I'll use the blue color for this. A, B, and C. Right, that's great. Then we can take the LCM. LCM is x plus 1 cube, x plus 1 into x plus 1 into x plus 1. Now, to cover 1 x plus 1, the A is x plus 1 into x plus 1. B, cover 2x plus 1s. You can say just 1x plus 1. C, cover all 3x plus 1, only C is there. Then you can write 3x plus 2 is equals to A times of x plus 1, x plus 1, plus B times of x plus 1 plus C. Right. Now, straightforward, I can find C by making x equals to minus 1. 3 times of minus 1 plus 2 is equals to, this is turned up to 0 and this one also turned up to 0, C. Therefore, C become minus 3 plus 2 is minus 1. Then to find A and B, what can we do? I just put x equals to 0 because there is no other common term over here. So you can put any figures you like. Then if I put 3, 0 here, 3 times of 0 plus 2 is equals to A times of 0 plus 1 is 1. 0 plus 1 is 1. It's 1. C is minus 1. With this, you can say A plus B is equals to, if I put this minus 1 to other side plus 1, 2 plus 1 is 3. I'll just keep this equation as my first equation. Then I can put x equals to 2. X equals to 1 because it's minus 1. I substitute over here. 3 times of 1 plus 2 is equals to A times of 1 plus 1, 2. And 1 plus 1, 2 plus B times of 2. So you can say plus C. C is minus 1. Then you can say this is 5 equals to 4b plus 2b, 4a plus 2b minus 1. With this you can say 4a plus 2b is equals to 6. This is my second equation. Now let's simplify these two as simultaneous equations. Just put it. It's 1 and 3. Next one is 4 and 2 and 6. Then x becomes 0. That means a is equals to 0. And b is equals to 3. Therefore, you can write this fraction. There is no a term. There is no such term. B is 3. So you can write 3 over x plus 1 squared. And c is minus 1. Minus 1 over x plus 1 cube. That is a partial fraction answer for this question. If I just go ahead with the page view, yeah, like this, it comes like this way. This is the answer for this question. And if I go to the first question, it's the previous question, it's like this. And the former question is this. And that other question is this, and we have started from this way itself. That's a way of understanding this question, right?